house. We ate it so much in college on the road playing baseball. That was always our breakfast spot, was Golden Corral, and you get real sick of that twice a week for 20 straight weeks. All right, let's get after it. Welcome back. Hope you had a nice weekend. Last couple weeks coming up, of course, seniors last week. Excited for you guys. It's awesome. Seniors, make sure I sign your checkout form sometime this week, okay? And the most important thing for that, for seniors, I know you guys have done Thursday and Friday is just kind of like a, the barbecue and stuff going on and powder puff and all that stuff. I am not here this Friday. Okay. Baseball is in Grand Junction. So I will have a sub here for us. It'll actually be Mr. Fields, I don't know if you had him. But he is, obviously he left teaching to pursue a different career and he's just kind of applying at this point to jobs. So he's subbing in the meantime just to make some extra cash. So he'll be here Friday to do whatever we do. Question?
Oh, I was just asking if he was going to start working.
I can't look at your face with that mask on and take you seriously.
Let me see it. What does it say?
How has nobody given you any issue with that today?
So many people are wearing stuff like that.
That's
I was just asking, I've been seeing him for like a week, and I was just wondering if he's like working here again, but you answered that already.
Yeah, just sub. But just for a moment, weren't you wearing a Virginity Rock shirt like last week? And now you're wearing a Tesla mask? I'm just confused. I'm just confused.
You get in trouble for showing your
It
shoulders.
means best of luck,
Right.
but in a different sense.
You don't get in trouble for that, Rosie, but you get in trouble for showing your shoulders. Sad times.
I know. And you have such nice shoulders.
Those are sort of fine.
So that's the deal for this Friday. I'm just not going to be here. And there is a possibility that I'm not here this Wednesday afternoon. Two things happened this weekend that I have to be at home to take care of. Number one, my alarm system in my house, my ADT is, they needed to upgrade my communication system so that ADT can get, fire alarms and burglar alarms and whatever. And of course, the window for the guy to come was between 12 and 5 on Wednesday. So, I have to be home to do that. So I might not be here Wednesday afternoon unless I can get that rescheduled. And my dryer died last night. The heat works, but it doesn't spin.
There you go.
And that's not good. So getting it repaired and just buying like a secondhand one is about the same price anyway. So I might have to get that installed this week because I now have a basement full of wet clothes. Because of course you don't find out that your dryer is dead until you've washed some clothes and try to put them in the dryer, and you hold the button down and it starts spinning, and then you let go and it stops.
Well, just sit there.
Bad news. Yeah, I could just sit there for an hour with my.
Doug said, yeah.
No, like the heat turns on, but it doesn't tumble. So I don't know if it's like the belt or the electronics or whatever. And it's so old, I might as well just treat myself. That's what adults do. We treat ourselves to new appliances. We get all excited about it. So that's what my life is.
You're going to be on like your Instagram, you're going to be like,
yo, check it out.
Yo, check it out.
Yeah, arm around it and everything. Default. All right, cool. Let's get back to it, though. We're going to jump back in basically where we left off yesterday, or Friday, I should say. And I just kind of want to recap what we talked about. So I'm going to go through 3 examples, but I'm also going to add like a little how-to over here for those of us that like to have like a plan written out so you know exactly what needs to be done. And what we talked about last time we were together were imaginary numbers, right? That happen when we take the square root of something negative. And because we're in chapter 2 technically, we're just going to do quadratics, right? So we're going to have things that look like this. I don't know, x squared equals, I don't know what I did, so I'm just going to make it up, negative 16. And it doesn't come up a whole lot, but I know next year a lot of us are maybe taking a class where this is going to continue, and I want to make sure that you have at least a decent baseline on which to build next year. And so we'll probably do imaginary numbers for the week or so, and then we'll switch gears for the last week to something just quick, just to kind of get you acclimated with, again, a different idea we just haven't talked about yet. I don't know how much time we'll have to really review and go over stuff. We'll see how it plays out. Certainly at least 2 days, but maybe a day or two beyond that as well. And so what should we do to both sides to start solve for x? If it's x squared. Square root. Yeah, let's square root both sides. All right, and so we're gonna, what's nice about that is once I take the square root of the left side, I'm gonna write it down here. Square root of the right side. What that does right away is get us into a nice looking spot. Now we just took a square root though, so I'm missing something. What am I missing?
Plus or minus.
Yeah, plus or minus is gonna go right in front of there. And what do we just get on the left-hand side? Right, and so we're always gonna get to here. X equals plus or minus the square root of some negative number. Like just in one step, which is really, really nice. But what we want to try to do once we do that is figure out kind of a best way to deal with this negative square root. And what we saw last time on Friday is, man, if that was just a square root of 16, life would be good, right? Just be 4 and I'd be done. But it's negative 16. And the only problem with this square root is the negative part of that. And so if we can separate it, and remove the negative from like underneath with the 16 and give it its own square root, right? Kind of break it up into 2 where the negative 1 gets its own piece, right? Splitting it up like this where the negative is at the end under the square root. Well, if I take just the negative out, what's left underneath? Yeah, just whatever the nice part of that number is, or whatever that number is. And that's a good first step, right? Taking the square root of both sides and then kind of breaking it up so that the nice number is kind of under the square root first, and then the negative kind of gets its own. Because like, what is the square root of negative 1? So just this part. You said it. I, yeah, like that is exactly I. Do you remember where I is on your calculator?
Above the decimal.
Yeah, above the decimal, second decimal, in case you ever needed it. And now the question comes to like, what do we do with that? Because there are a couple of different possibilities for what might happen here, right? The I, done, gonna be there for sure, okay? There's kind of 3 possibilities, right? For what might happen with the square root of just the number itself, right? Maybe it's a perfect square. Right? And so if that's a perfect square, then just take it. And when I say take it, I mean take the perfect square and like actually take the square root, see what you get. Like with this one, I think, Tyler, that was you saying it, right? 4, perfect, beautiful. And we just have the I attached. And we're done. Plus or minus 4i. So whatever's underneath that first square root, once we pull out the negative part, if it's perfect, sweet. 16, 25, 36, 100, 400, whatever. And if you're not sure if it's a perfect square, plug it in. And if you get a nice number, use it. Use it. Right? But there's a second possibility that whatever happens along the way, that they put a number on this right side that's negative, of course, because that's what's going to make imaginary numbers. Now, remember, right, we've got like real numbers sitting over here. We've got imaginary numbers sitting over there, real numbers, all of them. Here are all the imaginary ones. There's really no great symbol for imaginary numbers. But we could put them together and say, oh, a real number plus an imaginary, or a real number minus, like 2 plus 3i. This is like 0 plus 4i and 0 minus 4i. So there's a real number there, so 0. Do you remember what that system was called that had both? Because I know we're talking about imaginary numbers, but they're kind of part of a bigger system here. Started with a C is the symbol for it.
The complete number?
Congruent.
Close. Complex.
Oh, okay.
Difficult. Complex is a good word for it.
I just can't read my
Complex. Now, everything that has an I is a complex number. Everything that doesn't have an I is also a complex number. We talk about real versus imaginary. Yeah, those are two separate groups. Put them together, like consider them all in one group. It's a complex number. And it doesn't get any bigger than that, which is nice. All right, so number one, really nice. Love it. Square root of 16, thank you. Or I. Beautiful. No square roots when I'm done. But maybe not. Right? Maybe it's x squared equals negative 10. And we take the same plan here, right? I'm going to square root both sides. I'll put the plus or minus in front. I'll break the negative and the 10 apart and give them their own square roots. And you can do that as quickly or as slowly as you're comfortable with. Like writing it out, then breaking it apart, and then dealing with each one separately. That probably can't go much slower. But it's a nice path to take, right? Okay, cool. I'll take the square root of both sides. As soon as I do it, I put a plus or minus in front. X equals plus or minus, and I break it apart. And you see how similar every single question like this is going to be, but you might not need to show every single little step as you get more comfortable. You might say, oh, I know the negative underneath just means there's an I. Maybe you don't even give it its own square root. You just jump right to I, and you say, okay, I've got the square root of 10, I. Or you say, okay, I got the square root of 10 and the square root of negative 1, kind of breaking them apart first. And then you think about how to deal with it. When the square root of 16 was a square root, we loved it because that was perfect. I could just take it. What the square root of 10, is that perfect? No. And are there any perfect squares that go evenly into 10? Like just, well, 1 doesn't really count. Sure, 1 and 10, but it's not going to change the number. Does 4 go in evenly? No, that's 2.5. That's no good. No decimal. Don't want any decimals. 9 doesn't go in. It's too big, right? 9 decimal doesn't go into 10. They're too close together. So what's the best way to write the square root of 10? The square root of 10. And then the I goes at the end. Or if you want, if you're afraid that your square root will go too far and accidentally cover, like this is wrong. Okay, that square root does not cover the I because it was already under the square root. That's like the square root of the square root of negative 1. I don't want that. I just want one of them. So I got to make sure my square root ends. Or you play it a little safer and you drop the I in front of the square root so you can never make that mistake. Either one's fine. The top one's better because the I's at the end, but the bottom one's cool too.
So you say that if you cover it, that's wrong.
Yeah.
Is there going to be any point where if we cover it, that's the answer?
No, because already under the square root. So if you did it again, like I said, you have the square root of negative 1, and that's not. Is there ever a point? Not in this class and not in college algebra. That would be much, much, much further up that we would have the square root of complex numbers. That probably won't happen for us. That would be like an x to the 4th kind of equation where you'd have to take the square root twice to do it. But because we're just in chapter 2, we'll just do complex, right? So if it's a perfect square, take it. If it's not, then simplify, if possible. And that's why I have 2 versions here, because maybe you can simplify it or maybe not. Right? I guess I only have to say it once, but simplify if possible. And what I mean by that is kind of what we looked at a little bit, like once or twice. Let's see if I can pick a decent one. I don't know. We might have done this one on Friday, but let's do it again anyway. X squared equals negative 12. This will be the last example I do, then I'll give you a chance to try some of these out. Sure. So there you go. Square root both sides. We're going to do exactly the same thing. And you know what? Some people just, well, I'll just put it up here. I don't have to rewrite it. Maybe you just throw it on top of the problem that was given to you. That's cool too. Wherever you're comfortable. Plus or minus goes in front now because I really didn't have space to put it in up here. And hey, I'm already there. I already have my square root. Might as well break it apart. Nothing about the number changes except the sign. I'm just going to pull that negative 1 out. And then we think. And we look at the square root of 12 and we say, all right, is that nice? That's always my first hope, is that the square root of 12 is perfect. It's just not, right? It's 3 point blah, blah, blah. And it goes on forever. So I know it's not going to end up being some real nice number. But maybe I can write it a little bit simpler. Maybe I can use some smaller numbers. And we look at the square root of 12 and we ask ourselves those two questions. Is it nice first? The answer to that is no. So we say, all right, well, if it's not, maybe I can simplify. And that question really goes to saying, okay, is there a way where I can break the square root of 12 apart? Just the 12, not even the negative 1. That gets its own already. Can I go from not from 1 to 2 square roots, but 1 to 2 to 3 of them? Where this number underneath the first one goes evenly into 12, and it's perfect. Like, how do I get to 12 by multiplying two numbers together? Well, 1 and 12, all right, that doesn't change anything. 2 and 6, because 2 goes into 12 6 times, that's okay. But is 2 a perfect square? Is 6 a perfect square? No, neither of those are going to work, so might as well not use those. That doesn't make anything any better. What number does go into 12 that is a perfect square? Is there a number that you can divide 12 by evenly?
4.
Yeah. 4 is a perfect square, and it goes into 12 an even number of times. How many times?
3.
3 times. And that's what I mean by simplify if possible, where you break it apart, and this one is perfect. All right, that's a perfect square right there, and this is just whatever's left. All right, sometimes we have the square root of this number, and right, and we can just kind of break it apart into two separate pieces. And obviously, this is going to be the hardest one, right? Because it wasn't perfect, but we had some work to do to make it simpler. What is the square root of 4?
2.
Like, not the square root of 2, it's 2, right? So number changes, square root disappears. That's the best version of the square root of 4. What's the best version of the square root of 3? The square root of 3. And what's the best version of the square root of negative 1? That's good. Or you could put the I before the square root instead of after. I like the top one because the I is at the end. And you'll see why once we get to tomorrow. Why having that at the end makes sense. Okay, definitely the hardest ones are going to be the ones that are like this. Okay, super nice. Number 2, super not nice, but kind of easy, because all you got to do is leave it. And then the 1 and 2.
Now back on.
No, I can sign, sure, come on up.
Thank you.
You got it. Mess it up. There you go.
All right, thank you.
You're welcome. You get yours yet?
Do you get those in your English class?
English,
Yeah, I got that next. So.
Questions about these 3 before I give you? I'll probably give you like 2 of each kind to try. So we'll see how we do. Good? Let's find out. All right, cool. So let's say, all right, 1, 2, 3. So let's go like 4 and 5. Those will be like number 1. 6 and 7 will be like number 2. And then 8 and 9 will be like number 3. So x squared equals something negative. X squared equals something negative. X squared equals, x squared equals, x squared equals, and x squared equals. Now I just got to fix the next equals. Let's see. How about negative 36 and negative 81? Number 6, let's go like negative 13 and negative 21. And then negative 24 and negative 48. Okay, jot those down. Take some time. Like I'm good. More or less, as long as we can get through these, talk through them as well. And by the end, once everybody's had a chance to work through all 6 of these, which will take a little while, especially the ones like 8 and 9. I don't know how it's going to play out over these next couple of weeks, especially with me not being here potentially a couple afternoons. I don't know if you guys have noticed, but you know how many days I've taken off this year?
No.
0. 0, okay? Which means I have personal days built up. If I do not take them, I lose them. Okay, so there might be a couple afternoons that I take off next week as well, because I have the time, and if I don't use them, I'm gonna lose them. Now, the more likely scenario than me taking a couple afternoons off next week is that the day of finals, Monday, where we have 5th and 6th, and Tuesday, which is our final, there's a very good chance that I am not here the day of our final. Okay, my son is getting surgery on Monday the 23rd, 24th. It's not a dangerous surgery. It's not related to his heart, which is actually a good thing. It's just something else. So hopefully it's easy and quick. It's not super invasive, but they do have to probably knock him out so that he'll stay still. And that's happening on Monday. And so my guess is that I'm going to take Monday and Tuesday off so I can be home with him. Okay, which means I'm not here for your final, which is kind of a bummer because I like to be here when you guys are testing. But I can be online. I'll just be home while I do it. So if things do come up and whoever is here for me, if they can't answer a question that you need answered, maybe I can at least be there for you virtually. That's more likely than me taking an extra afternoon or two off, because I have to take a day and a half or I lose it. I'm just like throwing $500 away, basically, if I don't do it. So I'm not going to do that. I'm not throwing money away. But those days might just be, boom, there it is. Now everything's taken. So definitely not here Friday for baseball. I'm probably not here this Wednesday. And I'm definitely not here Monday of finals. But I might not be here Tuesday of finals. Those are really half days. I don't have to take the afternoon off. There's no class. Yeah, take.
I have a question.
Sure.
So the square root of 10 is unknown decimal, so it's
So what is that?
For this one, absolutely, right? That is 6. So I can change the square root of 36 to just 6, just like I changed the square root of 16 to just be 4. All right? But the square root of 10 was that long decimal, so there's nothing I can do about it. Plus, there were no perfect squares that went evenly into 10, right? Because what's the only way to multiply to 10? 1 and 10 and 2 and 5. None of those are perfect squares, bigger than 1. So that's the best way to write it. But with something like 12, right? 1 and 12, 2 and 6, nothing to do there, but 3 and 4, right? Which means 4 goes evenly into 12. And because 4 is perfect, I can simplify it. Right? Just like I did back here, right? Square root of 16, nope, 4, perfect. Right? Square root of 4, nope, 2, perfect. I just have kind of my 3 separate ones. I went from 1 to 2 and then 2 to 3. Rather than just 1 to 2 or 1 to 2. And so you'll see that happen with number 8 and number 9. I picked numbers that aren't perfect squares to begin with, right? 24 isn't perfect, 48 isn't perfect. But they do have numbers that go in to each one that are perfect. And it just makes our numbers smaller, makes them easier to deal with, so it's always great. So 4 and 5 are like 1. 6 and 7 are like 2. 8 and 9 are like 3. So you can kind of use those as a guide. And I'm actually going to start doing something over these couple of weeks. While we do have practice during class that I'm not collecting, like today, okay? I thought about starting this tomorrow, but hey, why the heck not? Once everybody's had a chance to work through these 6, so maybe in the next 5 minutes, 10 at the most, I want to find ways, because I don't know that we will, it kind of depends on how quickly things go, how much time I take off, whatever, and realistically, how much improvement to your grade you would like to have opportunities for. I don't know that we'll have like a lot of classworks, or if we'll have like another round of quizzes that have to do with complex numbers this week, or something next week that has to do with our last topic. And I don't even know if we'll have time to do that. Who knows? If I don't offer you a chance to make a big improvement now, your only chance would be on the final, which can help for sure, but that's going to help your test average only, right? It can't help your classwork average. And if you have been okay with your quizzes, but really haven't been doing a whole lot of homework and classwork, it doesn't matter how great you do, that homework and classwork average is going to drag you down. So what I want to do this week, from time to time, maybe once a class, maybe once every other class, is when we're doing practice like this, and definitely when I'm not collecting, but even sometimes if I am, I want to give you a chance to get a little bit extra credit kind of heading into the final. And so here's what we're going to do. And I've done this in the past, maybe with us, I don't know, maybe not, because of COVID stuff, but if you are willing and interested, and I choose you, because depending on how many people want to do it, if you put your work up on the board, right or wrong, I'll give you extra credit. And here's what it looks like. I will give you a point on an old homework. And I don't care if you got a 5 out of 5, and I'll turn it into a 6 out of 5. Okay, because that'll improve that category. And I know 1 point is not huge, but it can make a difference. Or half a point on a test for every one that you put up. Okay, and I want everybody to get a chance to do it, so I'm going to keep track separately. So I know, okay, like Jared hasn't gone 5 times in a row, and Bryson never got a chance. That's not fair. I want to make sure everybody has an equal chance to get up there, but it's volunteer basis first. If we get a lot of people interested, then I'll do kind of a randomized kind of thing. We'll just kind of pick names out of a hat. I'll use the internet to do it, but we'll randomize it for people that did it. So during 6 periods, 6 different people came up and had a chance to put their work up, right or wrong, and they got a point back. And you might get 3 or 4 opportunities to do that. That's like almost a whole homework, right? Your missing homework almost goes away. And so that would be, I think, worthwhile. Or, maybe, you gain a couple points back on a test. Not a huge difference, but hey, anything can help. So I'll wait another couple minutes. But is anybody done and interested in doing number 4? You got to be done first, though. That's the idea. Bryson, go ahead. So there's a couple markers right there, the red and the green. The green doesn't show up super great. The purple one's right in, like, so you can just help yourself to that. What about number 5? Anybody? Emma, go ahead.
Doesn't matter which one?
No, you gotta do number 4. Yeah, do 4. I'm gonna go in order here. Number 6. Ken, go ahead. Pick up like the red and the green on the stack right there. Here, actually, I should have done this. Folks at home can't even see. Yeah, Emma's gonna do 5. You're gonna do 6.
Okay.
Anybody want number
Do I just
7? No, write all the work that goes with it. Show me what you did to get there. Because what I want to do with this, not only give you extra credit, but give me a chance to help improve whatever you're doing. Anybody for 7? Yeah, I'll come back to it. Yeah.
Can you tell me if this works for me? Sure. I only know the answer.
So you can bring your work back. So 2 times 5 is definitely 10. That's true. But what's the square root of 2? Is it 9? Is the square root of 5 nice? So then what's the point? Like, why split up 10 into 2 and 5 if neither of them are going to make anything better? I go from 1 square root to 2 of them.
Whatever.
That's not good. I have more work, right? And so when you're thinking about 21, 1 times 21 and 3 times 7, and that's it. It's the only way to get to 21. And so is it really worth breaking 1 square root into 2 if neither of them can be simplified? And the answer is no. I just made it more complicated. I'm trying to make it simple. to me, simpler is definitely smaller numbers. And sure, 3 and 7 are smaller than 21. But I only want one square root at the most when I'm done. And so as much as splitting, like we said, like 10 into 2 and 5 is correct, it's not any simpler. Because I went from one square root to 2. And I want just one of them at the end. And so what you'll see happen once we get to 8 and 9 is that we can split them up. Like, right? 36 gets split up for a reason, because the 36 is nice and that's I. Right? The 81 gets split up because 81 is nice and that's I. 13 gets split up, but just 13 and 1 is the only way to get to 13. So I still end up with a square root when I'm done, but at least there's only one of them. Same thing with 21. 1 and 21, 3 and 7, none of that is good. None of that's going to help make things any simpler. So I'll just leave it as the square root of 21. Yeah. Sure. The people that put their work up, can you put your initials next to it just so I remember who did what so I can get you your points? Emma, Ken, and Bryson. Can you just put your initials next to your work just so I remember who? Because I want to make sure I give points to the people that want it. Plus, give everybody a chance tomorrow or Wednesday or Thursday or whatever to get a point or two extra credit.
Hey, Tim. I told you I had you. Can I go to the bathroom?
Sure.
I go that way. Oh my goodness.
If somebody gets to the point where they're happy with their work for number 7 and wants to put it up, or if they want advice on how to get better, again, you can be wrong. In fact, the best thing about doing this during 6th period was watching somebody make a small mistake and seeing how many people made the same mistake and then went back and corrected their work. That we would have never caught if you just sit there and do it yourself. Okay, so take another couple minutes. And if anybody wants 7 or 8 or 9, just raise a hand and you can go put it up. You already did one.
Oh.
I do 9.
You want to do 9? Go for it.
To do it again.
Yeah.
Is my setup right on this one?
Let's see.
Rosie, can I do 7?
Sure, go for it.
Yeah.
So,
Like new
not that the answers.
one?
Equal sign. And now it's like an X there.
It's not supposed to.
Well, it's supposed to just be like X equals plus or minus, and like there's your equal sign, there's your equal sign. You can't have an X on the right now. If there would be X's on the left here. I just think you like have this little extra square. It should just be square root of X squared equals. And then for some reason you have like another one. So just erase that square root of X squared that you got. And then I think you're good. If anybody wants number 8, it's up there. Plus or minus the square root of negative. Now
That's the right answer, right?
Minus comes down and break it apart. Oh, that looks good.
We're all neighbors. We're from, yeah. Couldn't grasp it, but I wanted to find out. You broke them.
We got it. We got Bryson, Emma, Kennedy. Tyler. Number 8 still available in case anybody wants some free points. Almost free anyway. All you gotta do is put your work up, right or wrong. Right or wrong. You get the points.
Unless there's plus or minus, it's just kind of tiny.
Okay. I know, like when you're up there, it looks big, right? But then you sit back down. I know. I did this like the words like perfect square, take it are probably so small. I forget how big this last one is. Yeah, I got it. Okay, good vision. Unless you hear me say, nah, I don't know what that is. Anybody? Number 8? If there's no other volunteers, I'm gonna give it to Ken, and she can get a second one. Go ahead, Ken. Yes, Dave. Yes. Kennedy wants that A. Give me that A.
I can't.
You gotta get a short girl stool for you.
Right.
Yeah, I need one too. I can barely reach that. And then we'll go through them. If you like got stuck on one, didn't know how to do it, now you have work you can look at. And if you maybe we made a mistake along the way, now would be a good time to talk about it and fix those. So if I get to yours and you put yours up there and there's things to fix, then fix them. Right? This is a great way to get basically one-on-one tutoring in the middle of class. Oh, free. Usually I charge $60 an hour for one-on-one tutoring.
I don't know if that's right, but
we'll find out. We're gonna find out.
Okay, thank you.
All right, let's take a look. Starting with Bryson's with number 4. Let's see if I can see it. So x squared equals negative 36. Nice. So x equals square root of 36 and square root of negative 1. Perfect, right? Split those apart. The thing that I think might be worth doing is like showing what you did to get there. Like show that step that you took the square root. There's also something missing since we took the square root. Yeah, plus or minus. And you can do that right away. Plus or minus right there. Plus or minus right there. There we go. That looks better. Now, I don't think you need to like show me the square root. Obviously, I know what you did to get there, but you want to be careful making sure that you kind of show every little step just in case. Same thing, Emma, if you want. No, you don't have to, but you could do that.
Okay.
Show that you've taken the square root of both sides, because then you can see how the results kind of match up. But I don't need it, because you got to the perfect answer. X equals plus or minus square root of 81, square root of negative 1. X equals plus or minus 99. Done. Love it. Good job. All right, number 6. Yeah.
Mr. Rosie?
Yeah.
Is there by chance, because I joined a little late, is there any chance like I can get like a screenshot of this after like when class is about to end?
Yes.
Or like I'll like screenshot my screen or something?
Yep.
All right, thank you. Appreciate it.
Okay. So, and what Kenny did is what I'm talking about, where you show where you've taken the square root of the left, and it's still there, right? We haven't actually done anything, and then she takes the square root of the right, throws a plus or minus, and breaks it apart. That's cool. Works for me. Square root of x squared is x, plus or minus square root of 13i. And I love it because the square root ends above the 3, and the I is separate, right? We don't want to keep that I underneath. So that's why some people move it in front, but it's better at the end. It is definitely better at the end. It's kind of like an x, like 3x, 3i. It kind of acts like that. That same kind of thing. It's not a variable, obviously. It means something, but it helps, right? Like that. Sweet. Love it, Kent. Nice job. All right. Tyler, right below that, number 7. Perfect. Square root of both sides. 21 and negative 1 separated. Next line, it puts the plus or minus in front. Good. The only thing is it looks like that it travels like just a little bit too long. Just shorten it just a little bit. Or if you're going to write it that long, then like move the I way away. And you can even like put a multiplication dot if you want in between. But just be careful extending that out too far. We want to make sure that that I and the square roots do not really kind of come in contact with each other. And box it up with them. Nice. Good. I like it. All right. 8. All right, so here's where things get a little bit tougher. Right, we start to look at 8 and 9, and we say, okay, square root of 24 is no good. Square root of 48, no good. Those do not show up as perfect squares. So we just try to do the best we can. And so Kennedy, what she did, took the square root of both sides, so it was a plus or minus in front, and she says, all right, at least let me take the negative part out. And let me work on the square root of 24 separately. And there's a lot of ways to get to 24, right? 1 and 24, 2 and 12, 6 and 4, and 8 and 3, right? There's a lot of different ways to do it. But the only perfect square factor is 4. And that's what she did. She broke it up into 6 and 4. And square root of 4 is perfect, too. Now, Ken, the only advice that I might have is to put the perfect square first so that the order stays the same as you work your way down. Now, it doesn't matter because multiplication, 2 times 3 and 3 times 2 are both 6. Order doesn't matter, so you're good the way you were. But if you want to like make sure you don't miss anything or, you know, whatever the case may be, I like to put the perfect square first and then see what happens. But I like it. Looks good. X equals plus or minus 2 square root of 6 I and square root of 6 ended. Love it. Okay, cool. Shared, right? Okay, cool. So square root of both sides, love it, plus or minus. And then he looks at 48 and he says, you know what? There's an I under there. I'm just going to take it out. Love it. I don't need to see the square root of -1 for 5 lines in a row. You see a negative under square root, boom, pull the I out. I don't ever need to see this. If you want to just go right to I, love it. And so basically what he's doing is he's saying, okay, now I've got this. And let me think about how to break that up so I can find a perfect square that goes in. And again, I like to put the perfect square first. So maybe we switch the order here just to be safe, but either one's cool. 4 definitely goes in. 12 times 2 root 12. Cool. But look at that square root.
Yeah, but then I was like, I don't know, like, because then it might have like
now what do we do, right?
Yeah.
Because when you get to the point, maybe it's tough for you guys to see, so let me blow this up a little bit. But he got himself to like here from the square root of 48, and he said 2 root 12. But we know root 12 can go further, right? How do you break apart 12?
3, 4.
Right? Put the nice one first. So 2 times 2, root 3. Numbers outside can go together. And so we could do it again. But I don't want to do it twice if I don't have to, right? Simplify it and then simplify again? No way. There's got to be a way for us to get there faster. Because 2 root 12 is better, 4 root 3 is the best. And so is there maybe a way that we could think about, and so don't mind me, can you think of a way maybe to break this apart so that we would get to here? Because if I can do it twice, then I should just only have to do it once. It just means that the perfect square that goes in is bigger than 4. Because maybe there's only one perfect square factor that goes in, but maybe there's 2, or 3, or 4, or 5. And we always want the biggest one so that we don't have to do it. Yeah.
16 and 3.
Exactly, because where did 4 come from? It came from the square root of 16, right? Now it makes sense going down this way. 48 is 16 times 3, and that for me is the hardest one to remember. That 16 goes evenly into 48. And so what you might do, so that you don't have to do it twice, is you say, okay, I'm looking for the square root of 48. And I know what my perfect squares are. And I say, well, if it goes in evenly, it's got to be smaller. And in fact, if it goes in evenly, it has to go in at least twice. So I better take this, cut it in half, and look at numbers smaller than that. But there's got to be at least something times 2. So take this number, cut it in half, that's 24. The numbers that go in are smaller than that. And sure, 4 goes in perfectly, but it actually ends up going in twice. Right? What's 4 times 4? There it is. Okay. And I picked 48 on purpose because of that. That 4 is always the one that we see first because, oh yeah, 4 times 12, I know that one. 16 times 3 doesn't stand out in my mind. It's something I easily remember. So you would have gotten probably a lot of the points to get to 2 root 12i, but not all of them because we could go a little bit further. But that's how you do it. Like maybe you don't catch it right away, but you say, oh, 12, I can keep going. That's 4 and 3, and then multiply those numbers on the outside. Cool. I'm good right there. I think we got a couple minutes, so I'll let you relax before we head off to 8. I'm going to pause this, like solving complex equations for the time being, and mess around a little bit more with this whole real number, imaginary number, put them together kind of complex number system, and teach you a little bit about that. Okay, so that'll be tomorrow. Like I said, there's a good chance today I am out here. We'll see. I'm going to see if I can reschedule 82. If I can get the dryer repaired or replaced. It's like 10 years old, so I might just keep myself in the dryer. I'm really excited. I don't know. We'll see that. So,
Hey, Mr. Rosie.
right now, and you're good to go. Liam, go ahead. You want to take a screenshot of that one?
I was actually gonna ask, is Carson there?
No.
Oh, okay. Is there any way someone could just like snap a picture and send it to me or something?
Somebody have Liam's number, Liam Rogers?
Probably not.
You can't take a screenshot?
No, I can take a screenshot. It's just that like, so I'm on my phone right now, and like when I pin like the your screen, it like doesn't even like come on like half my screen.
Oh, really?
That's why I've been like I can't really take notes because my
I'll
Chromebook's
take
dead.
a picture for you, and I'll email it to you.
For real?
Yeah,
All right, sweet. Thank you.
I got you.
All right.
You guys at home are good. I will catch you tomorrow.
Thanks, Mr. Rosie.